Alright, so today we're going to be doing 12.4, which is solving systems of equations in 3 variables. So, these are the types of scenarios that can occur when you're solving a 3x3 system. So a 3x3 system is defined by there being 3 separate variables. And in order to solve a 3x3 system with 3 separate variables, you're going to need to be given 3 different equations of those variables. And it's called an ordered triple. You haven't seen this written out yet, but an ordered triple is basically the same thing as xy, but it's in 3 dimensions. So it's actually x, y, z. And this is how you would write it as an ordered pair. So that's how all your answers are going to look, except for the exception of no solution and infinite solutions, of course. So x, y, z. So on the test, everything like that, that's the expectation of how your solutions are going to look. So there are 3 scenarios that can happen with a 3x3 system. You're either going to have infinitely many solutions, and this can happen in 2 separate ways. Now, when we're talking about 3 dimensions, we not only have height and width, like x and y, but we also have depth. So it's in 3 dimensions. So we have a plane, okay? Either those planes completely overlap on each other, like 3 pieces of paper lying on top of each other, those are the equations, or they intersect at such a way that they intersect at a perfect line. All 3 of them intersect on a line. Okay, that means you have infinitely many solutions. You don't really have to worry too much about that aspect of it. That's a little bit higher level, but just having a general understanding. And then one solution is where they intersect in such a way that all 3 planes have 1 point of common intersection. No solution can happen really 3 different ways. All 3 planes are completely parallel to each other in space. 2 of them are parallel and 1 of them cuts through it, because even though 2 of them intersect, all 3 have to intersect in order for the whole system to be a solution. Or we have it where they intersect with each other, but not all 3 ever, so you have like that open gap in the middle. Alright, so we're going to start with this one here. Now, go ahead and read through the steps. You're going to select 2 equations and eliminate 1 variable. And essentially, the main rule is you have to make sure you use all the equations. If you do not use all 3, that's when you know you're going to do something wrong. So all equations have to be used at least once. Okay, that's like the #1 rule about solving a 3x3 system. So, your goal is basically to use the other equations in a way that you eliminate one of the variables completely, and then you have a 2x2 system to solve. So, here's the approach that I take when I go about doing this. I go through each of these variables, okay? I go through the x's, the y's, and the z's. First thing I look at is, are there any that have any common factors? So 2, 3, and 5, do they have common factors? No. No, they don't all divide into the same number. What about 4, 5, and 3? No. They have 1, of course. You could just multiply them all together and get like 60. But we're trying to talk about if there's any simple ones, right? Now, once again, not these either. But do you notice how it's z? Just plain z? Yep. So those are going to be easy ones to work with, because I know I can multiply them by anything to cancel anything out with. So those are the ones we typically use in substitution and elimination that are more simple to work with. So our goal is going to be, because that one's, we can use this, we're going to be able to eliminate the other 2 z's with this equation. So what if I multiplied this bottom equation by 2? Can I add it to the second equation, which would allow me to cancel the z's? Now, in addition to that, separately, I can multiply the bottom equation by -5, which would allow me to cancel out with the first one. So we're going to do those 2 steps as separate things. Okay. So step 1 is I'm going to take this equation right here, and I'm going to multiply everything by 2. Distribute. That gives me -10x plus 6y minus 2z equals -34. Now, once I multiply that last equation by 2, I'm going to rewrite that second equation underneath it. Like so. And then what you're going to notice is I'm now going to be able to add these together, and when I do so, we're going to cancel out one of those variables, okay? So that's going to become -13x plus 11y, the z's cancel, equals -61. So what we're going to do is we're going to kind of table this equation and come back to it later. And our goal is to get another equation of x and y. So now I reduce it down to a 2x2 system. Okay? So we've already used this. Remember, we can use equations more than once. This right here is kind of what I like to call my anchor equation, because it's going to allow me to cancel out this z, and it's going to be used to cancel this one out. So how can I use this equation again to cancel this negative 5z out? Multiply it by negative 5, right? Because I want to get it to be a positive 5. So I'm going to take that anchor equation and I'm going to multiply it by negative 5. And like I said, you can do this differently. You might just end up with fractions. I try to do the path of least resistance when possible. That gives me a positive 25. X minus 15y plus 5z equals 85. Once I have that solved, I'm going to take that first equation and write it underneath this one. And then I can add these together. So I end up with 27x sorry, I was just checking my work. Minus 11y, and that canceled out, right? And this becomes 103. So is everybody with me on how I got there? Did you see any mistakes or anything like that? No, okay, just double check, because there's a lot of stuff going on. So, all right, so what you're now going to see is that we now have two equations in two variables, and now we just are going to solve it like a regular two-variable system. Now with these two equations, I think elimination is going to be our best bet, because what do you notice about the y's right now? They're the same but opposite signs. So if I go to add those together right off the bat, that's going to yield me a result that gets rid of one of the variables. So let's do that. So I add these together, I get 14x equals, oops, I did that wrong. 103 minus 61 is 42, which means x equals what? 3. So far in our solution, we have 3, and we still got to find y and z, right? So now that we know what x is, we can plug x back into one of the 2x2 systems to get y. So I'm going to plug it in here. So I get negative 13 times 3 plus 11y equals negative 61. That gives me negative 39 plus 11y equals negative 61. I'm going to add 39 to the other side, so I get negative 61 plus 39 is negative 22, which means y equals what? Negative 2. So now we know what y is. So now that we have two variables of our 3x3 system, we can go back and pick one of the original equations and plug in for x and y, which will yield us the third missing variable. So this is going to be 2 times 3 plus 4 times negative 2 minus 5z equals 18. So you could have picked any of the three original, your choice. So this is going to give me 6 minus 8 minus 5z equals 18. That gives me negative 2 minus 5z equals 18, which means negative 5z is equal to 20, which means z equals negative 4. So this would be the solution to my 3x3 system. Now, if you have extra time on your test that's coming up on next Thursday, by the way, this is the last lesson of this unit, by the way. We'll review for 3 days. If we plug these back into any of these equations, it's going to yield you, if you do it right, this solution. So like if you plug it in over here, it's going to give you negative 27. It's going to give you negative 17. And you can check all your work. All right. Next one we're going to look at is this one here. So what you may notice right off the bat in this one is there are no like just plain z's, x's, or y's without a number in the front, a coefficient. So what I'm going to go do is I'm going to look through and see which one has the most common, easy to deal with factors, right? So 3, 5, and 14, are those going to have easy factors to deal with? What about 5, 2, and 17?
No.
What about 2, 4, and 2? Those are going to be our easiest bet. So I know that I can use one of those equations to cancel each of those out, or various ones, you'll see. So I know right off the bat, what 2 can I add together right now that's going to get rid of one of those z's? Top and bottom. So I'm going to write the top one down here, underneath this one.
Does it matter which one you put like above or below?
Not at all, no. It's totally personal preference. So I end up with negative 11x minus 12y. These go away and leave me with negative 6. Now, I know I'm going to need to come up with another equation that also has x and y. And remember, I have to use all the equations at least once. So which one do I have to use this time? The middle one. So this middle one here. If I want to get rid of that z, what are some ideas to do that?
Plug this into z.
You could, but that's... What about if we took the last equation and multiplied it by 2? That's probably going to be the easiest one. You could have multiplied the first one by negative 2. That also would have worked, right? But I try to avoid dealing with any extra negative numbers when possible. Sometimes it's unavoidable, but avoid it as much as you can. So I'm going to distribute. That gives me negative 28x minus 34y plus 4z equals negative 38. And then now I'm going to take that middle equation and I'm going to line it up underneath this one. This is where I'm just really careful, checking my steps to make sure I don't make a mistake. Because you can be amazing at math, and I know a lot of you guys are great at it, you understand things, and you can make a simple mistake at any level. So just be careful. So this gives me negative 33x minus 36y. These cancel, equals negative 18. So now I have a 2 by 2 system that I can solve. So what can I multiply this equation by to? Yes, not just 3 though. Negative 3, because that will cancel out the 33's. So I'm going to take this one and multiply it by negative 3. I'm going to then take this and line it up right here. Cancels, 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 and leaves me with... If 0 equals 0, is that a true or a false statement? Which means what? Good. Infinite solutions. So if you look at that chart on your notes, that means you have one of the infinite solution situations. The only way to know which one, that's more complex, but if you put it in Wolfram Alpha, it will show you the plane. So if anybody is genuinely interested in seeing that, there is software that will do it for you. So does anybody have any questions about this one? You can probably take a guess on what the last one's going to be. Yeah. We always do one of each. Alright, so this one here. So this one's a little bit tricky because right off the bat, you see how we have a plane z? So you might think, oh, this one's going to be easy. I can cancel the 3, I can cancel the 7. But then we're going to end up with a situation where we're going to have to deal with these with all those numbers that have no factors in common. So you could do that. What I'm looking at is the x's. Everybody see the x's here? See how they all can be divisible into each other, basically? So I know that I can have a multiple for each one. So, right off the bat, let's talk about canceling the first, using the first and the third. What can I do? Yeah, multiply the third one by 2. Okay. So, that's going to become 4x plus 10y plus 14z equals negative 28. Like that. 58. I wrote it right. I don't know why I said that. Sorry. So then I'm going to bring this down. And then I'm going to combine these. Cancels. 8y plus 13z equals negative 43. Is that right?
Yes.
I'm second guessing myself. Yeah. Okay, so now we have one of our 2 by 2. So now, which one haven't we used yet? The middle one. Any ideas on how we can cancel out the 12x? Yeah, you have two options here. You could either multiply this one by negative 6 or this one by 3. I'm going to do the 3 one because less negative numbers, less room for error. But either one would work. And then I can line it up with the middle one. Cancels, cancels, cancels. 0 equals what? 90. Is that true or false?
False.
False, which means no solution.
Whoa.
What?
Nothing.
Oh, because it's such a shock. I know. So, like I said, you don't know which of the no solutions unless you graph it. Yes.
So does it really matter which one like we start out with?
It doesn't matter. It's just more of a, if you pick the wrong one, if you try to cancel out the wrong variable, you might have to deal with more difficult substitution, like multiplying 1 by a 7 and 1 by a 2. So if you don't approach it the right way, and even sometimes if you do approach it the right way, you might have to multiply like 1 by one number, 1 by another to get it to cancel. You're going to see that on the first question on the homework. So on the key up there, I did all the problems last night, but then this morning I realized